So before we get going today, one quick note. There's been one of your fellow students has put in a request for a volunteer note taker. So somebody who's willing to upload their notes to the website, which is listed on Quarkus, so that they can sort of have a little bit of help following along, or so that they can have a good set of notes. So if you're here on the regular, if you're taking notes and you're willing to share them, that would be amazing if you would sign up. There's some details on Quarkus, so there's that. Any other course business before we get going? Any questions about the test next week? Yeah?
Yeah, for the test, what is it going to cover, which classes?
It's going to cover everything before the test.
Oh, okay.
Yeah. Yeah.
Is that including the next week Tuesday lecture?
Yeah.
Okay.
Yeah. Yeah.
How long is the test?
The test is going to be 2 hours, which is, I would note, different than it has been in previous years. So in previous years, it's been a 3-hour test. I think that I am kind of doing you a favor making it 2 hours because my expectations for how much you're going to write are going to change proportionately. So in the past, I've found that people wrote, usually, like most of the class was done in 2 hours. They'd just written everything that they could think of. So I've shortened it. The expectations for how much you're going to write are going to be proportionately shortened. Still a lot of you, I'm still expecting you to write quite a bit. So if you write like 3 sentences for each of the questions, that's probably not going to be enough. We're expecting like paragraph style answers. I told you that I would post a sample question and some sample answers. I still intend to do that. I'll try to get to that as soon as I can. So, other questions? Yeah?
The review session yesterday,
Yeah.
for the ones that couldn't make it, is there information we can find?
Yes, I was told that there's going to be some notes posted on the Facebook page for this course. So the Facebook page, there's a link on Quarkus to the Facebook page for this course. It's set up on a volunteer basis by CASA, and they said at least that they would post some notes from their session. Other questions? Yeah?
In terms of the types of questions, will we have to be convincing you of something or just explaining an idea?
Right. So the structure of the test is going to be basically as follows. I'm going to just have a list of major terms. So it's really just going to be one block of instructions at the top, answer these questions, explain, do connections, that kind of thing. And then there's just going to be a list of terms. You're going to pick, I believe it's 6 out of the 10 terms that I list. And then what you're going to do is tell me, A, what that term means. You're going to define the term. You're going to explain how it's connected to other important debates. You're going to explain arguments for it and or arguments against it. And you're going to try to make connections between that idea and other ideas in the course. So you're trying to do this kind of like integrative thing where you're putting elements of the course together. Yeah?
How formal does it have to be? Can you use like analogies or kind of metaphors?
So what do you mean by how formal?
Let's say we're explaining, I don't know, categorization or something like that. We give a real world scenario that how a person would solve that with a certain model of it classified.
Right. That would be good. That would be good. A good way of filling out your explanation with examples. I don't need a hyper formal answer. I do want sentences arranged into paragraphs. Don't give me point form, that kind of thing. You can draw drawings if you like. What I'm really looking for is your depth of understanding of this stuff. And we've talked a little bit about in this class about what depth of understanding is. And so what I'm looking for is your ability to not just tell me what I've said to you, but to show me that you understand it, essentially by doing things like providing novel examples, generating novel insights. So if you have something that you've been thinking about these topics, and you get a question on something that you've been thinking about, giving me a novel connection shows me really vividly that you've understood what's going on. Yeah?
Does that also include kind of tearing apart some of these things?
Yes. So a novel critique is likewise evidence of a deep understanding, because it shows me, like if it's a really good critique, if it's a critique that shows me that you weren't really listening in class, that's a different thing. But if you present a really novel critique of one of the arguments or ideas presented, that's likewise evidence of deep understanding. Any other questions? Okay, just a reminder, it won't be in this room. I'll post the room location as soon as I can. We're not in the exam center. I think we're in, I don't want to say where I think we are because I don't trust my memory, but I'll post that location as soon as I can. It's a location with desks, individual desks where you have room to like write things rather than these desks which are fairly cramped. And also I can turn on the light. So one of the main reasons I don't want to work in this room, listen to what happens when you turn on the lights in this room. It's just horrifying. There's this buzz, this very annoying buzz. And the lights aren't even turning on.
They're warming up. They're trying so hard.
Yeah. Okay, so for a variety of reasons, we're not going to write in this room. And I'll post the room that we will be writing in shortly and remind you of it the day before the class before the test. Okay? Anything else we're wondering about? Good. So as usual, we'll do some quick review. We'll get into some new stuff. So again, we've been talking about categorization, or sorry, problem solving. We've been, again, trying to find the basic cognitive process in terms of which we can analyze, formalize, mechanize cognition. We've been looking at problem solving because we found problem solving at the core of both categorization and memory. This is what we called the interconnection problem. This sort of this knotty quality, that it's all knotted together of these problems that we've been dealing with. We seem to have to get to the root of memory, we seem to have to understand problem solving. To get to the root of categorization, we seem to have to understand problem solving. This frustrates our usual scientific method. So remember we talked about analysis at the very beginning, where the typical scientific method, the one that has worked so well for centuries, is you take something complicated apart into its parts and then understand the parts. That seems to be an extremely successful strategy for understanding things like stars and mountains and cells and proteins, and like so many phenomena that looked intractable have sort of revealed themselves through this process of analysis. And then when we go to try to use this process of analysis on cognition, you keep getting frustrated. We keep getting frustrated. So this is the interconnection problem, the problem that it's very difficult to pull cognition into simple parts. We've tried it twice already. We're on our third attempt. And each time we find that the parts that we pulled it apart into are not simple. They involve cognition themselves, which means that we haven't got to the kind of core of it. Okay, so recall what we talked about last time, this sort of broad review. Last time we started talking about problem solving particularly, and we looked at this search space model offered to us by Newell and Simon. So this was an attempt to analyze problem solving, and we made some progress on analyzing at least the parts of problem solving into a search, and the guiding metaphor was a search through a space. Recall that space was defined by a few things: the initial state that you're in, and then the goal state that you want to be in. So the problem is precisely the difference between initial and goal state. And then there was a kind of space of possible paths defined by the operators, right? So given a problem, you've got a goal state, you've got an initial state, and you've got a set of operators which are things that you can do to solve the problem. If your problem is, I would like to win a game of chess, the available operators are all the different legal moves in the game of chess. If your problem is, I would like to derive a theorem in logic, the different operators are the valid rules of inference in logic. If your problem is, I would like to make a sandwich, your operators are all of the things that you can physically do to manipulate your environment such that you can make a sandwich, right? So we've got a search space, and what we discovered very quickly about this search space is that for even the very well-defined problems for which the initial state, goal state, and operators are all very clear and well-defined for us, we found that nonetheless there became quickly we encountered a problem, which is that these search spaces become incomprehensibly vast very, very quickly. So the strategy that you might intuitively think that we use, which is just to look through the space exhaustively. Let's just look at all the possibilities in the space to try to find a pathway from initial state to goal state. That's not going to work. In general, I mean, there are some problems that you can do that for, very, very simple problems, but even relatively simple, well-defined problems, exhaustive search through the search space is just not going to work, right? Yeah.
I guess I'm a little bit confused with the initial state and what it means. So are we kind of assuming, let's say the game checkers, the start of the board, no players move, but is there not also initial state if I just picked up from a game that I left off that was halfway through and has everything
Sure.
in its position, you know, some people have made its move. Is that then considered a new initial state?
Yeah, you could call that your initial state. So
initial states don't have to be just the blank canvas. Like they can be half filled.
no, of course, yeah. So in the making a sandwich problem, presumably you're halfway through the problem in the sense that somebody's done grocery shopping, somebody's arranged your kitchen. Or with chess, very often the chess problems, if anybody does chess problems, they'll give you like the very end game and they say find checkmate in 3 moves or something like that. So your initial state can be whatever. So any time that you've got a problem in your life, you got somewhere that you're starting from, and whatever that starting point is your initial state. Yeah? Okay, so Newell and Simon tried to analyze problem solving into these parts, and they thought that they could provide an analysis not just of problem solving, but of intelligence more generally. So that what they thought was a problem solving method is a way of finding a pathway through a search space, and intelligence is having a collection of problem solving methods. To the extent that you have a large and effective collection of problem solving methods, you are an intelligent agent, right? Okay, so the problem, so there's a couple of problems here. So we thought this was, well, I presented this to you as not a bad attempt at analyzing problem solving, especially since it taught us some important things. One of the most important things that it taught us, I propose, is that we stand in the Thefinitary predicament. So this is a very early result of the Newell and Simon research program. This stuff about search spaces being unimaginably vast. We're always in this situation where what we need to do is somehow find a way of ignoring almost all of the possibilities available to us. Simply going through all the possibilities is not an option for us tiny finite beings. So we're in this situation where constitutive, so they originally defined intelligence as having a set of problem solving methods. You might want to add something to that definition, which is problem solving methods which help us avoid what we called combinatorial explosion, this problem of having to search through search spaces which are unimaginably vast, right? So ignoring information emerges as a key component of intelligence. And I propose to you that this is the state of the world right now. Yeah?
Are you using this term like as a synonym to the combinatorial explosion thing?
So they're very close. They're very close. So the Thefinitary predicament is just the predicament of any finite agent trying to navigate a world that's larger and more complex than they are. Combinatorial explosion is not something that we always face. So for example, when you're playing tic-tac-toe, like X's and O's, that's not a situation where you face combinatorial explosion because the number of possibilities to you is small. So that's, you're finite, but some of the problems you face are small relative to even to our finitude, right? So you don't need to search, to solve tic-tac-toe, you don't need to search through an unimaginably vast search space. The search space is manageable. So even though we're always in the Thefinitary predicament, we're always in a situation where we have finite cognitive resources. We don't always face combinatorial explosion. Okay, good. So the solution Newell and Simon proposed for dealing with computational overload, being in the Thefinitary predicament, and occasionally facing combinatorial explosion is heuristics. So heuristics are ways of biasing your attention, not having to pay attention to the whole search space, but biasing your attention to just a subset of it, some tiny little sliver of the search space where you're likely to find solutions. This was the stuff about heuristics, and we talked about a few heuristics. There's dozens that we could talk about, but just sort of giving you a flavor of the different possible heuristics. We had trial and error, which is just randomly sampling the search space. And I was fairly dismissive of this for most of the problems that you face, because for most of the problems that you face, the search space is humongous, and the instance of solutions is relatively rare. So it's like almost all of the search space doesn't contain solutions. So just randomly sampling isn't really a great way of going about it. We talked about the hill climbing heuristic, where you've got some feedback about where you're going, right? About how well you're doing in solving the problem. But had this hill climbing heuristic really only works in a very neat and even sort of search spaces. So when the search space is such that your feedback kind of gives you linear direction towards the solution, hill climbing heuristics will work. But if the search space is, they sometimes talk about rugged, that is, there are weird ups and downs that you've got to pass through to get to the solution, hill climbing heuristic's not going to work. We talked about the one that Newell and Simon actually programmed into their GPS, their general problem solving computer, which was the means ends heuristic, which was this kind of recursive process of finding an operator that you want to apply to get you to the goal state, and then trying to figure out which operator you can apply to get to that sub-goal, and which operator you can apply to get to that sub-goal of having the ability to apply that operator, and so on. So this was their proposal. I would like to, so this is not quite review. I did not say this word to you last time, I don't believe, but there's some worries about heuristics in general. So Newell and Simon's hope was that the means ends analysis heuristic could give them a general process for solving any problem. But that doesn't seem to have worked out as a potential solution to this problem of analyzing problem solving. Very roughly, because of the following. So I'm just giving you the intuitive version of this. There are much more formal, there's a variety of much more formal and precise versions of this, but very roughly, the no free lunch theorem says the following. If a heuristic is specialized to a type of task, then it will do very, very well on that specific task and worse on other ones. So if you take a chess playing program and give it checkers, it's going to do really poorly. It's not going to know how to deal with that problem. But if you make a general heuristic, it's going to not perform as well as a specific heuristic on the task that the specific heuristic is programmed for, right? So there's a kind of trade-off, a permanent trade-off between generality and being good at a given task. That's the no free lunch heuristic, or no free lunch theorem. Basically, it says if you're biasing your attention, which is what heuristics do, heuristics bias your search through the space in a way that helps you find solutions given some context. But because you're biasing it towards one area and not another, that means that your heuristic is going to fail you in some of the possible situations, right? So given a heuristic is a bias, your heuristics are going to fail you some of the time, right? In some set of possible situations, your heuristics are not going to work. So what you need to do is something like choosing the relevant heuristic for the situation that you're in. That's human level intelligence. That's human level problem solving. Is we don't seem to just stick with one heuristic. We assess what kind of problem we're facing and choose the relevant heuristic. Yeah? Okay, and then we talked a little bit about insight, which is when we talked about insight problems, where the situation that you're in looks like you should use one type of heuristic, but you've been misled. Something in the way that you framed the problem has misled you thinking it's one type of problem or best solved as one type of problem, but in fact is better solved as another type of problem. So in an insight problem, typically what you have to do is reframe the problem. You bring a different heuristic to bear. You say, this heuristic's not working, I need a different one. Or this algorithm's not working, I need a different one, something like that. So that was where we left off last time, with the idea of insight problem solving. And we're going to go ahead and just talk about insight problem solving for the rest of this lecture. So far, so good? Okay. So this was like the argument last time, one last thing. The argument last time was basically that Newell and Simon's search space model of problem solving left out the problem of insight, of understanding how to do insight problems, because the formulation that I showed you before, this initial state, the goal state, and the operators and the path constraints are all given, right? they're presented to the general problem solver, and then the only task the general problem solver has to deal with is searching the space. Whereas it seems much more realistic to say, those are things we generate ourselves, and sometimes we do it wrong. And when you've done this wrong, when you've picked out the wrong, say, goal state or the wrong operators, what you've done is got yourself into the situation where you have to do some insight solving. Yeah?
So is this kind of like akin to kind of book experience versus real world experience and how to apply your book experience? Or how does this, like, is there a point at which I could learn from a book how to intelligently make decisions with what I've learned in the book?
I think so. I think so. So today we're going to talk about the difference between propositional knowledge and procedural knowledge. So hang on for that and see if that answers your question. Because there might be some stuff in there that will help sort of clear that up. I think you can get insights from books, though.
What I'm getting at is like you kind of got like a toolkit of knowledge at your disposal.
Yeah.
And then you're trying to use that toolkit of knowledge intelligently. Is that what insight is? Or
I'm going to make an argument today that it's not quite that. That's what Newell and Simon thought it was, though. Okay, so let's get into it. So you're ahead of the game. Let's get to it. So talking about insight problem solving, trying to understand what it's like, how it works, trying to do an analysis of it. And today we're going to basically be comparing two broad schools of thought on how to think about insight problem solving. So on the one hand, we've got what we'll call the search inference framework. And this is essentially just trying to extend Newell and Simon's model that we talked about last time to insight. Saying, so there's one group of researchers who think, well, actually insight, we can just solve it like any other problem. It's a search through a space, just like non-insight problems are searched through a space. And doing insight problem is just a kind of action. That is, in just the same way that doing long division is an activity, doing insight problem solving is just an activity. We're going to compare that to the Gestalt tradition. So Gestalt psychology comes out of Germany in like the early 20th century, and they think, they're going to argue that insight involves perceptual restructuring. I'm going to go on at length about what that is. So perceptual restructuring, the way you're seeing the problem has to be changed more than just doing an activity on a problem that already sort of sits there ready to be solved for you. So it's more like seeing. Solving an insight problem is more like skillfully seeing than doing a thing. Of course, there's doing involved as well, but what marks something out as an insight problem is precisely restructuring the way the problem appears to you. Okay, so we're going to do a debate between these two. These are both like big schools. They're not just one or two people. Broadly ways of thinking about insight problem solving. So let's talk a little bit about the Gestalt psychologists. So they're kind of way ahead of their time, the Gestalt psychologists, in the sense that they're starting up in Germany in the early 20th century. They're saying things that are going to turn out to be more or less right, way, way before they had what we might be satisfied with as rigorous empirical proof. So they are not awesome experimentalists, especially compared to the 21st century standards of what counts as a good controlled experiment. And they're not super rigorous theorists either. That is, the theories that they're producing are kind of informal, deeply informal. They're not trying to formalize what they've got. That's just kind of not how things were going in the early 20th century in psychology. But nonetheless, I think that they've got some really interesting insights that'll be helpful when rigorous experimentalists and theorists come along and try to sort out this insight stuff. So talk about perceptual holes and perceptual restructuring. This is a Necker cube. I hope that you can all do something with this cube. When you're looking at this cube, you can make it do something. You can perceptually restructure this, right? You can do this thing where Sometimes one part is the front and sometimes the other part is the front, right? Give it a go. Hopefully you should be able to do this perceptual flip. If you can't, I suspect that you are a robot of some kind. Or maybe you just have a unique cognition. I don't know. There's lots of different ways of being a person. But this is what they mean by perceptual restructuring. So it's all the same parts, whether this face is the front or this face is the front. I hope we agree that the image has all of the same parts, but you're reconfiguring them into a different whole, right? So the word gestalt means the kind of whole, integrated wholeness of your perceptions, right? That's what a gestalt is a kind of integrated whole. And you've just got, this is an ambiguous figure, meaning that there's at least two gestalts that you can generate from the same parts. There's at least two integrated wholes that you can put together using the same set of lines on this slide. So when they're talking about perceptual restructuring, this is what they're talking about. They're talking about the sense in which, the way in which a lot of what we do perceptually is to integrate and sometimes reintegrate the same basic inputs. Yeah? Okay, so this is the kind of broad interest of Gestalt psychology. They didn't just do insight problem solving, but they did do a whole bunch of stuff about the way in which we perceive parts as integrated into wholes. Right? So you're not just receiving data. What you're doing is receiving data and integrating it into some meaningful, connected thing, typically. So, from their perspective, from the Gestalt psychology perspective, what is insight problem solving? Basically, it's when people get fixated on one way of gestalting the problem. So you get locked into one gestalt, but that gestalt, that way of integrating the parts of the problem, leads you down a path where you can't solve it. And what you need to do when you're doing insight problem solving, according to the Gestalt psychologists, is to break out of your initial formulation, the initial gestalt into which you put together the problem, break out of it, and then re-gestalt it into a new organization, a new way of putting those parts together into an integrated whole. Yeah?
Isn't that a lot like the hill climb heuristic, but where you allow yourself to restart randomly on different parts of the hill? Or in this case, maybe restart deliberately on different parts of the hill?
I think that's oversimplifying what's going on here. Because if you're just jumping around on the hill, it's the same basic landscape that you're operating on. Yeah? So the problem space remains unchanged if you're just jumping around.
So they're saying, like, change the hill.
Change the hill. In some sense, change the hill. In some sense, change the way that you have structured the problem from the ground up. Yeah.
In terms of like multi-atlas and convergence, like if this was information and I was perceiving it,
Sorry, if what was information?
like just this box,
Yeah.
there's a picture of it.
Yeah.
Am I creating new inputs as that converge to that box, or am I generating new conclusions from that box by seeing it different ways of generating them?
So are you asking for the Gestalt psychologist view?
I'm just trying to like model this as kind of like a multi-atlas or convergence problem, how we have multiple inputs and multiple ways in which we can apply formalization.
So I take it that here the lines have stayed, if you're doing the flipping the cube back and forth, the lines stay put. So the actual photons hitting your retina are not changing when you change from one way of gestalting it to the other. So it's constant low-level input. What's changing is your top-down processing. So we'll talk today about top-down and bottom-up processing. Your top-down is the sense in which you're integrating the thing. So what you're doing is the input, the low-level data that you're literally the photons hitting your eyeballs stay kind of constant, but you've got a new way of integrating that data.
Are we taking multiple inputs and then creating multiple formalizations from them? Like the same inputs, but multiple formalizations?
Formalization might be the wrong way of thinking about this, but you've got different ways of internally representing what you're seeing. Maybe that's a better way of. It's not clear that we can talk about the formal gestalts. I'm not sure if that makes sense. I'm actually unsure, not just rhetorically unsure. Yeah. Okay. So that's basically the Gestalt notion. Let's flip now. We're going to talk a little bit about the search inference framework and their attempts to kind of formalize insight problem solving in terms of searching through a space. Okay, so Weisberg and Alba are defenders. They're fans of Newell and Simon. And what they're trying to do is, so some people are critiquing Newell and Simon saying, hey, you haven't given us an account of insight problem solving. Your search space model is all fine and good, but it lacks an account of insight problem solving. And hey, these Gestalt psychologists have something different, a substantially different view of how this works. Maybe we should look to them and abandon your search space model. So Weisberg and Alba are going to try to defend the search inference framework, thinking about insight as just another search through a space, maybe a larger space, something like that. So the Gestalt psychologist said, as I just said, inference or insight problem solving is when you gestalted the situation one way, you get fixed into one gestalt, and then need to break out of it, break the fixation, and shift to another one. So Weisberg and Alba thought, here's what we should do. We'll try to give people cues, verbal cues that break their fixation, that tell them how to break out of their incorrect formulation. And if the Gestalt psychologists are correct, that should solve the insight problem for them. That is, that'll allow them to solve the insight problem. So they gave them the dreaded 9-dot problem, which has been studied 6 ways to Sunday. And they gave people the cue, think outside the box. They give them the 9-dot problem and tell them, they literally told them, think outside the box. This study is where that phrase comes from, by the way, which is ironic because what they found was that telling people that did not help them at all. There was no facilitation. When you tell people to think outside the box, even when the solution is literally thinking outside of a literal box, that didn't help them. So the conclusion that Weisberg and Alba come to is that the Gestalt psychologists are wrong. So they're basically destructively testing the Gestalt picture of insight problem solving, trying to show that fixation isn't the problem. That's not why people are getting stuck. So because they gave them a cue that was supposed to get them out of fixation, they didn't, therefore fixation's not the problem. Yeah?
Like, isn't that kind of a common phrase? It's not really like, do the lines outside the box.
No, that's where this phrase came from. This study was where it came from. So it wasn't a cliche back then. Now it's a cliche, but back in 1981, it's funny and horrifying because I guess people heard the phrase but didn't read the conclusions of the study. Anyway, okay, so they're trying to. Here's the first salvo in this back and forth. They're trying to show that the Gestalt picture doesn't work. Okay, so what is their alternative? What are you proposing, Weisberg and Alba, as an alternative way of thinking about insight problem solving? So this is, again, within the search inference framework. Basically, they think insight problem solving is a memory search. It's a search through your memory. So what you're doing when you're trying to solve an insight problem is thinking through all of the problems that you've solved in the past, looking for one that resembles the problem you're trying to deal with in the present. And you're just searching through your memory for similar problems such that you can find the right formulation of the problem and then solve the problem. So Weisberg and Alba sort of say this in passing. The main source for this is Chris Cherniak, Minimal Rationality. So they're certainly not suggesting, and we just talked about the Thefinitary predicament. We just talked about how Newell and Simon are keenly aware of the Thefinitary predicament. So they're not doing it. They haven't just forgotten that. They're perfectly aware that it's a humongous computational task to search through every problem that you've ever solved in your life. But remember this thing that we said about memory. So before the levels of processing approach to memory, we had this picture of memory as kind of just a series of boxes. right? So you got memory boxes where you store various memories, categorize them. You categorize your memory, you store them away in boxes, and when you need them, you pull them out of the box. So their analysis, Weisberg and Alba and Cherniak's analysis of insight problem solving is you look in the first box that you can think of for a solution. Okay, you can't find it, fine. Then you switch boxes. You go to a different box or look there. If you find a solution, you don't find a solution, you switch boxes. And this was their account of, I hope that you've all experienced this, the phenomenology of insight. So the feeling of having an insight. I hope that you've all feel like when you're stuck and you're frustrated and you go, oh, they call it the aha moment, right? It's literally one of the best feelings I've ever had. I love the feeling of insight. It's such a dopamine hit. So it's amazing. I think it's why I'm addicted to philosophy, honestly. So they think the characteristic phenomenology of insight, this feeling of having an insight, is when you switch to the correct box, the correct memory box. Okay. So there are some problems with this, which hopefully some of them are floating around in your head, but let me kind of go through them. So this is a paper by Dan Chiappi and John Verveake, criticizing this as an attempt to understand insight problem solving. They got a bunch of problems with this, and some of them will be familiar from stuff we've talked about already. So for example, think about our critique of the box picture of memory, the picture of memory where it's just a bunch of boxes. What goes in a given memory box? And if you recall from the stuff about memory, we said that should be context sensitive, right? So the way in which you encode your memories depends on the way in which you're going to need them in the future, but your needs and goals change over time. Remember that story about the two kids playing? They had subjects read a story about two kids playing in their living room, and then you either read the story as a home invader or a home buyer, and you remember different things based on those two different goal sets. So which box memory goes into seems to be context sensitive. And how do you decide which memory box to search? Again, that seems like a really smart, context-sensitive thing which you need to do. Furthermore, even if we give the memory box thing, let's give them this memory box thing. Let's assume that what we've got are a bunch of boxes where our memories are stored. Those boxes, when you search in a box, you're really just finding what's typical for that box. What's standard, right? But humans seem to be able to do better than that. We don't just find typical solutions. Sometimes we find novel solutions. We find solutions that are unexpected. That's part of the delicious rush of having an insight, is that you didn't expect that solution to be a solution. That's what makes it kind of, well, I mean, for me, that's part of the rewardingness of it, is that the solution is often atypical. It's something that you wouldn't have thought of. So it's not just like you've forgotten how to solve a connect the dots problem, right? It's that you've got a type of solution that you never would have expected to apply in that situation. Okay. Here's another one. So just I'm just gonna lay down a whole bunch of problems for this. So furthermore, problem solving can't just be a simple memory search, because solving problems often involves putting together information that is distantly related. So you think, oh, this is like a problem I encountered in my elementary school education with a problem I encountered in a video game with a problem I encountered in a personal relationship, and you put them all together. Somehow we do this. We're able to assemble parts of a solution from seemingly distantly related parts of your memory. And if you're searching just within one memory box, if your memory is just compartmentalized into these little boxes, you're only able to search one of those little boxes at a time, right? So you would expect solutions to only be found, these things are context sensitive, you'll only be able to find solutions in one tightly constrained context. You could say, but what if you're searching all of your memories all at once? Again, that seems to push up against the Thefinitary predicament. That seems to be a combinatorially explosive problem. Their solution for that combinatorial explosiveness is to have you search one box at a time. That was their solution, so that doesn't seem to provide a solution for distantly connecting things that are way over here and way over there and putting them together into an insight. Huh? Okay. We got more. So here's a different critique from a different paper, Dominowinski. So Weisberg and Elba seem to be, he says, assuming a single difficulty hypothesis. That is, so with the think outside the box experiment, for example. With the think outside the box experiment, they said, look, we tried to solve their fixation because by telling them to think outside the box, and if the fixation was really the problem, that should have solved it. But they were just dealing with one of the problems, right? Remember we talked about the different ways in which people typically misframe the 9-dot problem? There was the going outside the box issue, but there was also the rules of connect the dots where you're not allowed to change direction except at a dot, right? So that seems like there's at least two things that are kind of clear misframings of the 9-dot problem, and they really only solved one of them. So the Gestalt psychologist didn't say that fixation was the only issue in doing insight problem solving. Breaking fixation might be necessary, but it's not sufficient. So their claim is that often we have to solve multiple problems at once. And that seems to be a thing that we're perfectly capable of doing. It's very hard to see how that could be the case if insight problem solving is just searching through memory boxes, right? So here's an example of multiple simultaneous constraint satisfaction. Here's a thing that you can do. Read those words. Everybody doing okay with that? We all felt that that was an accomplishable task? Huh? What does it say? The cat. Okay. So how did you, but of course the H in the and the A in cat are pixel for pixel identical, right? Okay. So how did you do that? In order to read the letters, you have to know what the word says. But of course, in order to read the word, you have to know what the letters say. Therefore, reading is impossible. Okay, no, obviously reading is possible, even when some of the letters are weird, right? So somehow, there's two constraints on this problem. The problem is read these words, okay? You've got two constraints. The letters are ambiguous, the words are ambiguous. You need to read the words in order to read the letters. You need to read the letters in order to read the words. And you did them both at once. You solved these mutual simultaneous constraints on the problem, right? So problem solving, the claim is often like this. It's not just that there's one issue and you're just dealing with that one issue. So if it was just one issue at a time, that would be easier, right? What you do is search through your memory for a similar issue and try to apply the solution that you used last time. But if you've got multiple problems that are interacting with each other, that's not going to work, right? Yeah?
That might be true. I mean, I'd say this, the words the and cat, couldn't it be that like those are such common words that we recognize them as like distinct categories in and of themselves. So the word cat looks like the word cat. That looks like the word the. And you're not reading the word letter for letter. You just immediately recognize the word cat. I'm just wondering if you provided a word that maybe wasn't common or a word that somebody hadn't read before, if you get the same result.
I think that you do. So I don't have a study for you, but I can tell you from anecdotal experience. reading cursive, I'm bad at reading cursive. When I'm writing, I print. I haven't written cursive in a long time. And what I do when I'm trying to read cursive, often the letters are ambiguous. And I figure out what the letters are by figuring out what the word is. And I figure out what the word is by figuring out what the letters are. So I think that you're often doing this mutual simultaneous constraint satisfaction when you're reading, especially when the script is unclear, which happens with printing too. But like, you figure out what the letters are by knowing the word. But obviously you can't know what the word is. Like, how do you, the question is, how did you know that that was cat?
Right, so it would be, I don't want to use the word, I want to be specific with the word context. So if you're reading cursive,
Yeah.
and you see a word that the letters don't seem like very legible.
Yeah.
So it's their fault, my fault.
Thank you.
But if you look at that word, the way that you'd understand that word is based on the surrounding words. Right? There
Yep.
has to be there
Yep.
has to be a level, because there are, like, I imagine there's a badness, a point where the writing is so bad that you wouldn't be able to read it.
That's right. Yeah.
Right? And that would be, there's no words that you understand.
Yep.
You'd understand each individual word based on the surrounding surrounding.
Yep.
There has to be some kind of
So
recognition somewhere.
you just added, I think you just added another level to this process. So sometimes I can't figure out what the letters are. And I try to read the word as a whole. I can't work out what the word as a whole. So I look at the sentence as a whole and then use that to constrain the possibilities for the word, and that constrains the possibilities from the letters. But again, the letters have to be the baseline for how I'm understanding what the word is, right? So I'm using multiple levels of constraints, all putting constraints on each other. So how do I figure out what those letters are? Well, I look at the words. And how do I figure out what the word is? Well, I look at the sentence. But then how do I figure out what the sentence says? Because I'm obviously not, like, if I don't need to know what the word is to understand the sentence, I'm not going to go through all this. I need to know what the sentence says. To figure out what the sentence says, I need to know what that word says. And to figure out what the word says, I need to know what the letters say. So there's a kind of like mutual constraining between these levels of understanding that come together sometimes, hopefully, for me to be able to understand what those parts are. More generally, I hope that, so this is an example. I hope that this example works, but more generally, it just seems like problem solving often involves not just these constraints, but like multiple constraints that you're trying to solve. Trying to cook dinner, I'm trying to cook dinner in a way that is affordable and relatively easy and that will please my girlfriend. Those are three mutual constraints that I'm all trying to solve all at once, right? So if you just look at all the times that I cooked a tasty dinner, that's not going to be sufficient for me to solve all of my constraints all at once. So is that all right?
Yeah.
There's room for debate. So especially with the cat, I think you're making a plausible case where you could say, like, look, I just know what cat, there's not that many letters that middle letter could be, so you just know what cat is. But I do think that there are more complex cases where you genuinely do need the both top-down and bottom-up processing to put it all together. Is that all right? Okay, sorry, yeah.
Is this not also an issue of like how many constraints that we need to apply to be certain of what we're about to do? Like
That is an issue.
shallow, too deep versus like, and likewise, if you expand it, like at what point are we actually certain that we've applied enough?
When you get the solution, I think is the only point in which you can be certain, and maybe not even then. I'm sorry, you can't say certain to philosophers. We don't believe in that.
Okay.
All of your knowledge is confidence or high degree of belief or something like that. Yeah.
So, with respect to this problem of the cat, like,
Yeah.
you're only basing up the cat off of what you know, the context in which it's written, the previous words, but that still could say, you know, the shit or whatever.
Shit.
Yeah.
It could, yeah, that's right. Yep. Welcome to the messy world of gaining knowledge. I think that's just the general case that we never are 100% certain about anything. I know you hate that. I know. I feel you, but that's just as far as I can tell, that's just the situation we're in epistemologically. So, okay. So far so good. We've been looking at a bunch of critiques from two different papers, trying to show that this sort of picture, the Weisberg and Alba picture of insight problem solving as just a larger search through a larger space. So Newell and Simon presented to us problem solving as searching through a space, a problem space. Weisberg and Alba, in order to deal with the problem of insights problem solving, said, okay, let's just search through a larger space. And we've been looking at some of the critiques of that. Let's talk about the Gestalt way of dealing with this stuff. So let's talk a little bit about what does help facilitate insight problem solving. So here's another problem on another study on the famous 9-dot problem. They found that verbal cues didn't help people solve. So telling them think outside the box or similar related things really didn't improve people's performance on this, which, recall, the people's unaided performance on the 9-dot problem is very close to nobody gets it, statistically indistinguishable from nobody gets it. Verbal cues didn't help, that didn't improve people's scores. I mentioned this already, but here's the study. Here's what does improve people's scores. Drawing a big box around the 9 dots. Now, people get this. Not everybody, but like a substantially increased number of people solve the 9-dot problem. So what's the difference between that and saying to people, think outside the box? Why are those different? So one of them, telling people to think outside the box, did nothing for them. Drawing a box actually helped them. Yeah.
So this suggests that they didn't actually know what box they're thinking of?
Maybe. So they didn't realize which box they're supposed to be thinking outside of? Possibly. Here's a different way of interpreting this. So this is not a propositional cue, right? They're not giving people a set of words that add up to an idea here. What they've done is redirect their attention. They've provided a different way of perceptually organizing the space. Right? They've given them a different way of paying attention to the problem by literally framing it differently. And that seemed to help people solve insight problems. So for the rest of this lecture, we're going to talk about, so this is the Gestalt, and recall the Gestalt idea. Gestalt people say insight problem solving is a matter of perceptual restructuring, not inferentially crunching through a problem space. It's a matter of seeing differently. Notice just briefly how little education you've probably had in directing your attention. Mostly that has involved people banging on tables and saying, pay attention, right? Like that was your education. In terms of paying attention, you got threats and yelling, mostly, unless you had a very different education than I had. That's basically what I got. You get lots and lots of training on propositions and manipulating them and inferences, but very, very little training in shaping your attention in a dynamic way. You can train in this, by the way. That's what meditation is. Meditation is training in shaping your own attention, where it goes, how it moves, that kind of thing. So there is training available if you want it. But for some reason, we sell higher education as building a new generation of insightful problem solvers and give you practically no training in the skill that seems to be fundamental to insight problem solving. Okay. Anywho. So let's make a distinction between a couple of different types of knowledge. Knowledge that, which I called earlier propositional knowledge. So proposition is a sentence that's true or false about the world. And procedural knowledge, knowledge of how to do things. So there's lots of, you've got lots of propositional knowledge, facts that you know about the world. Typically, you are only said to know something propositionally if you can produce the sentence. So if I don't know that Paris is the capital of France, if I can't say the sentence or think the sentence, at least Paris is the capital of France, that I don't know that. But procedural knowledge seems to be much, much harder to put into words. So imagine trying to, I don't know if have you ever tried to teach somebody how to ride a bike? You say, you put your feet on the pedals and you twirl them round and round. Okay, so I've said that sentence to you. Does that now mean that you've gone from a non-bike rider to a bike rider? No, of course not, right? You can say those sentences all day long. You can give them exquisitely detailed models of the physics of riding a bike. So they have all of the relevant propositional knowledge. Teach them about gyroscopics and balance and all that stuff. That doesn't make you able to ride a bike. And furthermore, you can be perfectly well able to ride a bike without having any of that propositional knowledge in your head. So these are, I mean, and when we talk about knowledge, especially in philosophy, we almost exclusively mean knowledge that, propositional knowledge. But know-how, skillful procedural knowledge, seems to be an incredibly important domain in which we are either, like, we can build skills and have a kind of abilities or whatever. Yeah? So the Gestalt proposal, this proposal that I'm kind of developing on behalf of the Gestalt psychologist side of this debate, is that insight problem solving, yes, it does involve propositional knowledge, but it crucially involves a special type of procedural knowledge. Specifically, the ability to change the way that you've structured your attention on a problem. Right? And that's not knowledge that. That's not a proposition in your head. It's a skill that you can acquire, skillfully restructuring your attention. Right? So, it's a skill that can be scaffolded. You can help people. So this box around the 9 dots is a way of helping people, facilitating their procedural ability to restructure their attention, restructure the way they've gestalted the problem. Right? When you give people a proposition, propositional knowledge about how to do this, it doesn't help. When you give them procedural, perceptual cues, it does help. So that's supposed to be an argument for the idea that insight problem solving has a lot more to do with perceptual restructuring than it does with having propositions in your head. Okay. So we're just going to do a bunch more arguments basically along those same lines. So here's a nice study by Janet Metcalf. We'll look at a couple of studies by her. And she's using what's called a cognitive probe. So a cognitive probe is when you really have a good set of experimental data on one phenomenon and you know it's related to another phenomenon. So you use the first thing to study the second thing. And the first thing, the well understood thing in this case, is what's called the feeling of knowing. So feeling of knowing as a probe to investigate insight. Now, so feeling of knowing is when you're trying to remember something. So what's the capital of Alberta? And regardless of whether you know the answer or not, you had a feeling about whether you knew or not. You either like, oh yeah, I probably know that, or no, I probably don't know that, right? So feeling of knowing. The thing that's well studied is the relationship between feeling of knowing and eventually coming up with the right answer. So if you've got a really robust feeling of knowing, even if you can't recall at that moment, oh, what is it? I know this. That's actually very predictive of your ability to eventually come up with the correct answer. So feeling of knowing is predictive of success in a memory search. Searching through your memory, what's the capital of Alberta? I know this. If you have a strong, robust feeling of knowing, it's very likely that you're eventually going to come up with the right answer. That's a kind of well-established, outside of her research program, it's a kind of well-established result. So she's going to use feeling of knowing to investigate insight. How does she do that? Well, the proposal from the search inference framework people is that insight problem solving is a search through memory. And if that's right, she says, then feeling of knowing should predict success on insight problem solving. Insight problem solving is searching through your memory. Feeling of knowing predicts success on memory searches. That means feeling of knowing should predict success on insight problem solving. Does that little syllogism work for everybody? Okay, so what did she find? Well, she found that there was very little connection between feeling of knowing and success in insight problem solving. So what she did was give people either feeling of knowing, she gave people either insight problems or non-insight problems. In non-insight problems, like, what's 15 times 24? Right? That's not an insight problem. That's a problem you know exactly what kind of problem it is, what operators to apply, or insight problems like the 9-dot problem, mutilated chessboard, and that kind of thing. So, and ask people. So she presents the problem and then asks people to rate their feeling of knowing in the standard way. So here's the problem. Do you think you're going to be able to solve that? For non-insight problems, people's feelings of knowing was very predictive of their ability to eventually solve the problem. So you give somebody a, 15 times 24, people are like, yeah, I got this. I know I'm going to be able to come up with a solution. For non-insight problems, the feeling of knowing was very predictive of success. For for insight problems, there was no correlation. So sometimes you show people an insight problem, they're like, yeah, I can totally get this, and then they just don't. Sometimes you give people an insight problem, they're like, I don't think so, and they do. So it's uncorrelated with eventual success. You can have high feeling of knowing, low feeling of knowing, and that doesn't predict whether you're eventually going to solve the insight problem. So that's supposed to be a bit of evidence against the idea that insight problem solving is searched through a memory space. Okay, so there's that. She's going to do further studies because she's a little worried that feeling of knowing is a kind of snapshot. You ask them at the very beginning. You present the problem, ask them for their feeling of knowing, and what she wanted was a finer temporal resolution. So she wanted to know in a kind of moment-by-moment way, how close do you think you are? So she's got another construct, feeling of warmth. So how close are you right now to a solution? So ask them every 10 seconds, how close are you now? How close are you now? How close are you now? And people are giving them kind of hot and cold ratings. Oh, I feel it. I'm really, really close now. Or, no, I don't think I'm close. I don't think this is going to work. So, for insight problems, starting off with a feeling of warmth, high feeling of warmth, actually predicted failure. So people who saw an insight problem and right off the bat they're like, oh yeah, I can totally do this, actually was predictive of failure. Not everybody failed, but like if you started off with like high confidence, that you were more likely to not get the answer. What was predictive of finding solutions for insight problems was actually an abrupt increase in your feeling of warmth. So you start off low or medium or wherever you are. You say, I don't know. And then right before finding the solution, their feeling of warmth shoots up. Oh, okay, now I'm onto it, bam, they get it. So again, the feeling of warmth, if it's just searching through memory, should be tightly correlated with how close you are to a solution, but high feeling of warmth does not predict being close to the solution for insight problems. A spike is what seems to be correlated. A spike in feeling of warmth. So again, this seems like a problem for the search inference framework thinking about problem solving. Okay. Newell and Simon have a response to this bit. So they do have a response. Simon introduces this term satisficing, which is a portmanteau of, so you mash together the words satisfy and suffice. Satisficing. I think every academic should be allowed to invent 3 new words in their career. You get, sometimes it's important to invent a new word. You get 3. I'm looking at you, Heidegger. Okay. So, satisficing is good enough for many, many tasks in your life. Last night, I attempted to make myself an omelet. I failed, but I made instead scrambled eggs, and that was fine. I was close enough to the thing that I was attempting to make. I was satisfied. So what they suggest is that a lot of the time what we're doing in problem solving is satisficing. We're saying, look, getting to this goal X is really, really hard. Y is actually pretty close to X, so getting to Y will do. That'll be fine, thank you very much. But for insight problem solving, that's usually not okay. So with a 9-dot problem, you say, I'm going to cover all 9 dots with 4 lines. You say, well, I get 8. It's good enough, right? So that doesn't really count as a solution, right? Getting close enough in insight problem solving, satisficing isn't really an option. So their suggestion is people's feelings of knowing and feeling of warmth can be explained in terms of our tendency to satisfice and the fact that insight problem solving, because they typically specify the solution very tightly, it's got to be, this heuristic is failing us. And that's why feeling of knowing, feeling of warmth doesn't predict success on insight problem solving. So that's the kind of pushback from Newell and Simon. Yeah? Okay. Let's heap yet more misery on this. Okay, so back to the other side of it. So back, another study by Metcalf, this time Metcalf and Viba, intuition and insight in insight and non-insight problem solving. So they had people do, again, feeling of warmth ratings on insight and non-insight problems. And they asked people to say out loud what they were doing when they're trying to solve these problems. So this is very common in psychology studies. Just ask people to talk through what they're up to and hope that their reports about what they're doing are reasonably accurate. And what they found was, for non-insight problems, their metacognition, their thinking about their own thinking, that's metacognition, they had accurate metacognitive reports. So you're doing long division, you can pretty accurately report what's going on in your process. Now I'm carrying the 3. Now I'm bringing it down the column. So you can tell, you can reasonably accurately say what you're doing and how it gets you to your goal. But not on insight problems. People didn't really seem to have great metacognitive access to what's going on when they're doing an insight problem. And that kind of fits with the Gestalt picture of how this goes, because you don't really have access to the way in which you're perceptually putting the world together, do you? I mean, I don't. Maybe you do. If you do, that's awesome. But I just see objects, right? The object just appears to me. When you're looking at that Necker cube, that cube that can be one way or the other, it just kind of flips. And it seems to be flipping in a way that's almost outside. It's kind of on the borderline of my conscious control. You can kind of, if you focus, you can make it flip. Sometimes you try to make it flip and you can't, right? So this perceptual gestalting stuff seems to be at least partly unconscious, if not fully unconscious. So having access, conscious access to the process by which it happens seems to be unlikely if it's a process of perceptual restructuring. So, and the takeaway is basically the more well-defined, the less insighty the problem was, the more accurately people could report on their own process, and the more accurately feeling of warmth ratings tracked your closeness to the conclusion. Okay. Hopefully you're at least a little bit worried about the self-reporting stuff, because as we said before, self-reporting are mostly suspect. You should be a little bit worried about self-reports. It's always nice to have an independent line of evidence. So here's an independent line of evidence. We've got a replication of Metcalf and Viba, but of course you're not allowed to just do a replication. Despite how they taught you the scientific method in high school, you don't get grants for replications. You don't get a grant to just do a replication, except under very special circumstances. You got to put a little twist on it. So the twist they did here was to ask for feeling of warmth, but also monitor people's heart rate. And if you look at the paper, they lay the graph of heart rate over feeling of warmth, and they match up almost exactly. So self-reported feeling of being close to the solution was correlated with an increase in your heart rate. You get excited. People love solving problems, so they get excited when they're near the solution of the problem. So here's just an independent line of evidence for the idea that this feeling of warmth stuff is tracking something real, and that it's tracking something that has a relation to your ability to solve at least feeling of warmth on non-insight problems. Again, there's a kind of gradual ramping up. Heart rate was gradually ramped up. In insight problems, there was this pattern of like low feeling of warmth, or like not that warm, and then a spike when people were about to solve the problem. and that was correlated with a spike in like your biology. We're thinking a little bit about the fact that this is, like, why does your heart rate go up when you're going to solve, like, this is a biological, metabolic correlate of the problem-solving process. Like, you're consuming, your brain is consuming more oxygen, so your heart rate needs to go up. So there's something like at the, even, like, it's not just happening in your brain. Cognition is not just, what this tells me anyway, cognition is not just happening in your brain. It's your whole organism is involved in these processes, right? You need your heart to be pumping more, because when you get the insight, you go, and a whole bunch of new stuff lights up in your brain. New connections happen, and you need more oxygen and glucose to keep those processes going. So you need your whole body like working to get your cognition, like to keep up with your cognition. We're gonna talk quite a bit about the kind of metabolic constraints on cognition. The Thefinitary predicament is not just like a computer science-y thing. It's that your brain spends precious, precious energy to think. And that's a deep constraint on your thinking. So your brain takes up about 5% of your body mass and consumes about 20% of your calories. It's metabolically incredibly expensive. And evolution doesn't let that just happen for no reason, right? Your brain is a gas guzzler. And it's going to be trying to, if there was a much more efficient way of organizing your brain that brought it down to only 10% or 5% of your calories, evolution would have been heavily motivated to push us in that direction. But currently we have these very metabolically expensive brains, and that's kind of the biological side of the Thefinitary predicament. Thinking takes precious energy. Yeah?
Like you would describe that your kind of insight or aha moment makes you feel great. It tickles your brain, you get a flood of dopamine. Is this also not kind of an excitatory response of like, I'm being rewarded because I've solved a problem?
Yep, yep.
So how do we then know that, like, okay, it's not just that our brains require more resources versus that I'm getting, a little biscuit dangled in front of me for, doing a task correctly? Yeah,
you could be right. So that's an alternative explanation. Yep, that's good.
Did they get into that?
No, so for their purpose, so that little coda I just put on there is foreshadowing hours and hours of argument that's going to come later in this course. Their thing was just that there is the fact that your heart rate goes up. For them, it doesn't matter whether that's correlated with increased metabolic expenditure or just excitation. It's just that there's a biological correlate to the feeling of warmth ratings, which is just an independent line of evidence that sort of tells us that something important is going on here. There's an important difference between how you're dealing with insight and non-insight problems, which is a deep problem for the search inference framework. For this class, that's the important bit. Good. Okay. Good with that? Right. Okay. Another study. So, Schooler et al. Had people describe their thoughts while trying to solve insight and non-insight problems. And what they found, so what they did was compare people trying to solve them silently from people trying to articulate them, and what they articulate their processes, and they actually found that this interfered with insight problem solving. So if they force people to say out loud what their process is, they will do worse on insight problem solving than if you let them just sit there silently. But not non-insight problems. For non-insight problems, you're doing long division, saying things out loud seems to make no difference. It's not a problem. This is, This seems to be fairly general, actually. So procedural knowledge, when you have a skill, if you make somebody say out loud what they're doing when they're doing their skillful activity, it reduces your performance, which is why every anime you've ever seen where they're saying out loud what move they're doing is not, like, that's not the thing. Anyway, okay, so, right. So they called this effect verbal overshadowing. Verbal overshadowing. So what you're doing is forcing people into an inferential mode. You're forcing people into a linguistic propositional way of being, and that seemed to make it harder for them to solve insight problems. Now, I'm going to argue later that the problem is not language exactly. It's not language particularly, but we'll come back to this later. The problem is not necessarily language. It's more being in a propositional rather than procedural mode. Okay. But a nice sort of having, so this is a nice bit of evidence, right? We're trying to decide whether insight problem solving is inferential or perceptual in nature. If it's inferential, seems like saying what's happening in your head shouldn't be a big problem. But generally speaking, it is it doesn't make it impossible to solve an insight problem, but it makes it harder. Where if it's perceptual, that might make it harder. If it's procedural knowledge, that does in general interfere with people's ability to skillfully perform their procedural knowledge. Therefore, this is evidence, I suggest, for the Gestalt side of the insight problem solving debate. Okay. So another nice thing that comes out of this, not just their people's performance on the tasks, but the things that they say were interesting as well. So you got a whole bunch of verbal reports out of this experiment. People talking through what's going on. So when they're solving non-insight problems, they said a bunch of inferential stuff. They said, well, if this is true, then that's got to be true. They cited the rules of inference that they were using. They talked like a logician or a mathematician when they were doing this stuff. They talked in inferential terms, right? If this and this, then that. If this or that, then the other. This kind of inferential language. Whereas when they were trying to solve insight problems, people did a lot of pausing, and they made more metacognitive reports. So they made more reports about their own process. So rather than just cognitive reports, now I'm carrying the 4. That's a cognitive report. They make a metacognitive report. I'm trying to think about, or like, I'm trying to, you know, they're talking about their own cognitive process rather than just reporting the content of that process. Does that make sense? Is that fairly clear? Okay. And we can correlate that. We can correlate the content of these reports with people's eventual success on solving these problems. So inferential language was highly predictive of people solving the non-insight problems. So if you're using this inferential language, that's predictive of your success. Whereas nothing much was predictive of success on insight problems, except pausing. Pauses were weakly predictive. The more pauses people took, the more likely they were to eventually solve the insight problem. Yeah?
I don't know how connected this is, but could it be that we're looking at like non-insight problems and insight problems as problems, whereas I mean, it seems like insight problems seem to be very like cognitive, like just a taxing act for the brain and body.
Yep.
And it also seems to imply like insight problems tend to require some degree of learning, right? So if we classify like insight problems as like you're learning and non-insight problems as you're actually solving a problem, wouldn't that kind of describe some of the differences in how both physiological response as well as right? Because it's difficult to explain something that you haven't fully learned yet. So if you're learning when you're solving an insight problem, then of course there's going to be more metacognition because you're thinking about something that you've never really thought about before and trying to understand something. Whereas a non-insight problem, you kind of already know the rules, you understand.
Interesting.
Interesting.
Yeah. So that's an interesting thought. Trying to think through how could we test that? So giving people a learning task that doesn't involve insight and then asking them to articulate their thought process. So if they're good at that, that would be evidence against the difference is insight involves learning and non-insight doesn't involve learning. I'm just trying to imagine what would be the conditions under which we could test this hypothesis. So if you give people like, try to learn this bit of programming language, and it's just sort of like fairly straightforward, just like I'm just acquiring bits of propositional knowledge and inferential knowledge, and if they're able to talk their way through that without interference, then we would know that it's not just the learning part that makes it the difference between insight and non-insight. But if it does interfere, if people say, if for example, people learning just some programming do a lot of pausing, do a lot of metacognitive reports, that would be evidence in favor of the difference between the two being just learning. Yeah, yeah. I'm going to show you some evidence shortly that seems to, like, so this is, I mean, that's a, given just this, your hypothesis seems quite reasonable, and we could think about how to test it. I think on balance, the evidence I'm going to show you pushes us towards the difference being also between perception and inference. So we're going to do some really perceptual stuff at the end of this lecture. So, but yeah, no, it's a very interesting thought. Yeah, yeah, yeah. Hi.
So if pausing was weakly predicted while they were doing verbal reports,
Yeah.
could that just be because they're doing less verbal reporting because verbal reports hurt your insight problem solving?
Yeah, it could be.
Like, so
Yeah.
it's just another piece of evidence that doing verbal reports is bad for insight.
Yeah, that could be the case. Yeah, yeah. So they're just sort of refusing the task temporarily. I just introspectively, when I'm working on an insight problem, I often don't know what my brain is doing. Like it's not clear what the operations happening are. So if somebody asked me to report what was happening at that moment, I would just be like, I don't know. I see colors and shapes and things happening inside. But yeah, that seems like an also a quite reasonable interpretation of just like verbal reporting hurts. They're just not doing as much verbal reporting. That's why it helps. Yeah, yeah, good. Okay. How are we feeling? Okay. Okay. So here's another way of studying this. It's what's called the individual differences methodology. And here's the basic idea. You've got, if insight and non-insight problem solving draw on different cognitive abilities, right? So you've got one set of cognitive abilities that lets you do non-insight problems. You've got another let you do insight problems. You should be able to test people's cognitive abilities in those two different domains. Like you should be able to test how good are you at this thing and how good are you at that thing. And it should be predictive of your success or failure in both insight and non-insight problem solving. So you're taking the same person, giving them two different types of tasks, seeing how good they are at them, and then testing their abilities on insight, non-insight problem solving, trying to see if this person, that individual, has differences in their abilities in different domains. And if those abilities in different domains are predictive of your success on insight, that suggests that those cognitive abilities are related to how you're doing insight problem solving. All right? Okay, maybe it will be more all right if I show you an example. So, Schooler and Melcher found the thing that was most correlated with your ability to solve insight problems was blurry image recognition. Your ability to look at a blurry image and tell what it is seems to be well correlated with your ability to then solve problems like the 9-dot problem, the mutilated chessboard problem, and so on. What? Huh? Why should that be? So what does it involve to identify a blurry picture? What are you doing? Well, yeah.
Inferring shapes.
You're inferring shapes, yeah. You got a bunch of parts that are unclear. And it's not obvious what the whole is, right? So what's this whole picture of? I hope this hasn't baffled you utterly. I hope you're all worked out that this is a bird, right? You got that? Blowing anybody's mind right now? Okay, good. Okay, so but before you figured that out, you're like, I don't know what this whole thing is. I don't know what the whole is. And furthermore, it's blurry, so you especially don't know what the parts are, right? So both the parts and the whole are unclear. And what you're going to do is attempt to resolve both what the parts are and what the whole is, kind of in a mutually constraining way. Well, if it's a bird, that's probably a wing, and maybe that's a beak. Yeah? So you're identifying the parts by identifying the whole. You're identifying the whole by identifying the parts. What it's likely that you're doing is just throwing out a bunch of different hypotheses, a bunch of different ways of gestalting the thing, and then testing them out. Right? You're saying, is it a bird? Is it a plane? Is it Superman? It's a bird. So you're doing rapid structuring and restructuring of your perception. That's the thought. That's a hypothesis. So what was established is a correlation. So let's be clear what this experiment establishes. What this shows us is that being good at identifying the content of blurry images is well correlated with being good at solving insight problems. And then it's up to us to decide what that means, of course. But I've tried to make the case to you, I've been doing this whole time, trying to make the case that this has something to do with perceptual restructuring, our ability to grasp the relationship between parts and wholes, to quickly restructure our perceptual experience. And again, this is all meant to be in service of the argument that insight problem solving is as much a perceptual task as it is an inferential task. Okay. So here's another one. Same people. They were doing field-independent tasks. You probably can't see it very well from here. This is a Where's Waldo. So why is Where's Waldo hard? It's okay. You're all solving, hopefully you're all vigorously trying to find Waldo. Did everybody do this? Am I too old for this example to work? Okay, so like you saw Where's Waldo, the task is to find Waldo. Now, if this was just, why is Where's Waldo hard? Why is this a challenge? Insofar as it's a challenging task, why is it challenging? Yeah.
Lots of information, similar shapes, lots of people.
Fair. Exactly. So, and especially I want to pick out on what you said, that there's a bunch of things that are roughly similar to Waldo. They're almost always like a bunch of people. If it was Waldo and a bunch of like black and white squares, it would be pretty, like there's a lot of information in a bunch of black and white squares, but it wouldn't be that hard, right? Because Waldo would stand out as very different. What you have to do is a whole bunch of little, like, is that Waldo? And you're like looking at this area. So you're looking for like, sorry, here he is. So you're looking for the red and white stripes, right? Guys? Yeah. So you're looking for red and white stripes. So here's an area of red and white. Is that Waldo? Here's an area of red and white. There's a red and white thing here, right? So you're looking for the features, and you're having to like quickly do little gestalts, right? You resolve, you say, here are the features that I'm looking for. Now I have to resolve this into a whole. It's like, that's not Waldo. So here's another set of features that I'm looking for. I'll resolve this into a whole. That's not what I'm looking for. So field independence tasks are when you're trying to sort out a huge amount of information that involves quick perceptual structuring and perceptual restructuring. So your ability to do this quickly seems to be also predictive of success on insight problem solving. So if you were good at Where's Waldo, you're a genius. Not really. Okay. But again, this perceptual task seems to be predictive of success on insight problem solving. Okay. Here's another one. Another thing. We're still within the, sorry, yeah.
Can we not use our previous insights in a more inferential kind of method to solve things? So what I kind of had aha moments before. And
Of course.
Okay, well I know the artist draws Waldo in a certain way. I know, I came up with that before. It's like I know he's using a certain pattern with like the the frame or whatever,
Mhm.
can I not like computationally solve that problem then? Rather than kind of use insights towards it?
Well, so your original question was, can't we use previous insights in a computational way? And I think, yes, absolutely.
What I'm trying to get at is like, at what point does an insight become a memory, and what point, or just kind of like
Well,
a
after
rule
you-
that we produce versus
So,
a hunch or a feeling to intelligently use a set of.
no, that's one of the great things about insight is that they can generate. So once you've had the insight, other than in cases of psychology classes where they're trying to trick you, or psychology experiments, the great thing about insight is that once you've had the insight, you can often apply it to a whole bunch of different places. So it becomes a rule of inference that you can use to treat previously nasty, ill-defined problems as well-defined problems.
I didn't understand that.
I will happily explain it to yourself. That's great. That's funny. That's the first time that's happened. Do you know what's funny? There used to be that classrooms were full of cell phones ringing, and everybody seems to have solved that. This is the first time that a computer's actually talked back to me. That's fun. I like that. Yeah.
So like by extension, do our insights also tell us how to use it? Like, well, they should tell us how to use our previously incited insights.
That's right. So one way of thinking about the flow state, you know the flow state where you're like, so lots of people report this. If anybody's done first year psych, you've heard of the flow state. So it's when you're kind of like engaged in a skillful activity that's right near your ability, right near the maximum of your ability to perform. And you get into the flow state, and one way of analyzing the flow state is precisely as a kind of insight cascade. So you're putting skills together in novel ways, saying like, I see how to put this ability together with this ability in a new way, and it's a kind of insight. And that gets you sort of like excited and happy and confident, and those are all good predictors for your ability to do better at problem solving. And that lets you have a new fresh insight where you roll in another skill and another skill and another skill. Flow state is an immensely rewarding state to be in, and what you're doing is, one way of analyzing what you're doing, one potential hypothesis is you're having a kind of insight cascade where previous insights are rolled into new insights, and those new insights are immediately rolled into even newer insights, and on and on and on. So yeah, I mean, insights do become, in one sense, they become the computational bedrock for you to move forward. That's what's awesome about them. Okay. Okay. Here's another one, less perceptual, but remote association tasks were weakly predictive of your ability to do insight problem solving. So what do these three words have in common? Magic, board, and hole. What could you associate with all three of them? Yeah. Black. Black magic, black hole, black board. Huh? Okay, so it's remote association. Right? So you're trying to see what's connected, what connects all these distantly related things together. And that's precisely the kind of thing that the search inference framework doesn't handle well, right? We saw earlier that the sort of searching through memory boxes seems to be, you need that to be sequential to avoid combinatorial explosion, but this problem is precisely asking you to search a bunch of different non-related memory tasks, memory boxes, supposing there is such a thing as memory boxes. You're insightfully putting these things together by distantly connecting things. Things that appear, like if your memory is memory boxes, they'd be in very different boxes. Yeah?
How do we then avoid kind of computational explosion of insights being fed into more insights? That seems awfully recursive as well.
No, that's awesome. You want to seek that out at all costs. Insight cascade, yeah. That's what flow. I just made the argument to you that that's what flow is, and flow is one of the most rewarding experiences you can have.
But like the amount of information produced from one insight must kind of remain more or less the same. Otherwise, we're going to be passing large amounts of more information to our newer insights, and that's just going to turn out getting worse. We get very computationally expensive after a while.
Sure.
In terms of like what we pass to our new insights, are we also making an insight of like what we should pass and what is relevant?
You must be. You must be. You must be, in some sense, it's not just like you're not just generating information. You're, in some ways, an insight constrains the information that you have to deal with. So remember the mutilated chessboard. The mutilated chessboard example, that framing this as a tiling problem, just trying to like snake dominoes across the whole board, there was way too much information to deal with. But when we framed it as a parity problem, the search space, the challenge of the problem went way, way down. So oftentimes, an insight compresses the problem for you, makes it much easier to handle. Yeah? Okay, good. Okay. Can I keep, so I got 4 slides left. We might not finish within an hour. I try to only ever give you 50 minutes at a time, but can we just do you want to just push through?
Yes.
Okay, okay, good. By the way, the last few classes, a few people have hung around. We've had a fun discussion after class. You're all invited to that. So we're having kind of like an informal seminar, like tutorial thing after class. You're all invited. Okay, good. Okay, here's another one. So the distantly related things was predictive, mildly predictive of insight. Here's 2 things that were not predictive of insight. Category generation. Name a fruit that starts with P. Peach. Okay, good. That's a kind of memory search, right? You're just trying to, I've got a bunch of fruits indexed by first letter. I'm going to go through my letter index. That's a memory search. So being good at that was predictive of non-insight problems. So your ability to solve well-formulated problems was predicted by category generation, but not insight problems. Anagrams also were not predictive. Did you know that if you Google the word anagram, you get, were you looking for nagaram? Huh? Huh? Okay, I'm the only one who thinks that's funny. That's fine. Okay, so an anagram is when you take a series of letters and rearrange them into a new meaningful whole, right? And that's kind of a memory search as well. So you're just kind of searching through the space of possible arrangements of those letters. And again, predictive of non-insight problem solving, but not predictive of insight problem solving. So, yet another study. I'm just giving you, this whole lecture is just study after study of different individual, so this second half has mostly been just individual differences, methodology, trying to figure out what predicts people's ability to have insights. Here's another one. They tested people's ability to do what they called cognitive leaping. So they gave people these images. This is, the top one is clue number 2. So clue number 1 was just a few dots, and at each clue, so they give them more and more clues and say, when you know what this is, tell us. So as soon as you've figured it out, tell us what this image is of. And it turns out that the fewer cues, the less information that people can have, but nonetheless get to the correct answer, the better they're going to be at insight problem solving. Once again, so cognitive leaping, the ability to just jump forward and figure out what it is based on very little information and based on clearly messy information, right? So clue 2, I don't think I would have guessed that that's a couch. That's just like a mess of dots, right? But the earlier in this process, the less information that you have, and you're nonetheless able to jump to the end, the more likely it is that you'll be good at insight problem solving. Again, this seems to suggest a perceptual skill, insight problem solving as a skill of perceptual structuring and restructuring. That would be my proposal to you. Yeah? Okay. Yep.
Would practice doing this make you better at insight problem?
I don't know. I don't know.
Or is it just like you're just good at it and it just shows you what you're good at?
So the only thing that I know that actually improves your ability to solve insight problems is meditation. So training your ability to flexibly apply your attention does improve insight problem solving. That's the only thing that I know that's actually been studied. It would be a very interesting study to see if doing this has the same effect. So the answer to your question is I don't know, but here's another thing that I know does actually improve insight problem solving. Yeah. Yeah. Yeah.
And I think that it would because, I haven't studied it, but I seem like
Mhm.
with a lot of riddles and things that you have to think outside the box, they're actually better at solving these things. So I
Huh,
would
yeah.
guess that it can help.
Yeah, yeah. I mean, that's what I would guess as well. Yeah. I mean, if I had to predict, I would say that doing a bunch of insight problem solving makes you better at perceptual structuring and restructuring, and that would sort of apply generally. That's just just a guess because I don't have any robust studies to back that up. But okay. Okay. So the general lesson here is that it looks to me like the evidence suggests that insight problem solving is more perceptual than inferential. It's not that it doesn't involve inference, it's not that it doesn't involve reasoning in a traditional sense of thinking through propositional knowledge. Both are clearly involved. So if you give somebody an insight problem like the 9-dot problem, they're still doing the kind of line fitting stuff, right? They're still like thinking how the lines fit in the same way that it would be if it was a non-insight problem. But the thing that distinguishes an insight problem seems to be that it involves restructuring the way that you see the problem in a literal way, like you're literally restructuring your perception of the problem, not just thinking through within the problem. Yeah?
What about if that were the case, would a consequence of that be that, like, let's say you were born blind?
Yeah.
Would your ability to solve insight problems be just totally different from somebody that can see?
I don't think so because it's not the only sensory modality in which you can restructure your attention. So, okay, so I've been talking about visual insight problems, but yeah, so that applies across sensory modalities. So you can give somebody an insight problem that you just tell them, or something like that. Or you could give somebody a tactile version of the 9-dot problem, and it would be the same thing. Your perception of things is, I mean, vision is my go-to because it's a very common sense, but like, yeah, I think this would apply across sensory modalities. Yeah, yeah. Okay. Okay, so where that leaves us is we're thinking about problem solving. We tried to think hard about it. We tried to analyze it. Our first attempt, the first attempt that we looked at, Newell and Simon, kind of stumbled on insight problem solving. It says we found that they left out this crucial problem of problem formulation. So what we did was just sort of drove down directly into that problem. Let's think about the way we formulate problems. And insight problem solving is a really nice probe for doing that because it seems to involve not just problem formulation, but problem reformulation. When you formulate a problem one way, you get stuck. You need to reformulate it. So that brought us to the kind of Gestalt tradition. We found that reformulating a problem is as much a process of perceptual restructuring, of restructuring the way you see and perceive and attend to the world, as it is to refiguring the way that you're thinking about it. So now we've gotten as far as trying to understand problem solving not just as an inferential process, but as a perceptual process. And that's where we're going to go next time. So on Thursday, we're going to continue to dig down into the perceptual dimension, the attentional dimension. So we're going to start talking more directly about attention as a process and how attention feeds into insight problem solving. So that'll be next time, and we're done for today.